We just finished up with the law of sines. And so the next thing on the list to talk about is the law of cosines. In the law of cosines, there are two situations where we think law of cosines. One is where we know two sides of the triangle and the included angle. If I know an angle somewhere else, then that's not overly helpful. Okay, but two sides and the angle in between them. Or if I know all three sides and none of the angles, then I'm going to think about the law of cosines. Now remember, the law of sines had three parts to it. We had that sine A over A is sine B over B is sine C over C. All those ratios are equivalent. Well, here there's three versions of the law of cosines, and it depends on which side you're after, or which side you know. And so one version says c squared is equal to a squared plus b squared minus 2ab cosine c. Now, notice, just kind of as a random thought, that if my angle is a right triangle, if C is a 90-degree angle, the cosine of 90 degrees would be 0. This would be gone, and we'd have c squared equals a squared plus b squared. Okay, so one, I'm not going to say proof, but example, demonstration why the Pythagorean theorem can work. Okay, if we want to find b squared, then that would be a squared plus c squared. I can say it, but I can't write it today. Minus 2ac cosine b. Or if I'm after a squared, that's b squared plus c squared minus 2bc cosine a. Notice that these letters are the same. If this is a and b, that's ab. Okay. If this is side c, this is angle c. Okay. Side b, oh, that should say cosine b. Okay. Side a, angle a here. Your author, if we use college algebra, if I add this term to the other side, if I take the c squared over here, if it's the angle that we're after, if I solved the top equation for cosine of c, for example, it would be a squared plus b squared minus c squared all over 2ab. Again, that's just college algebra. Add this to the other side, subtract the c squared, divide by the 2ab. And then, of course, we can use the inverse trig functions and take the arc cosine of both sides to find out what angle C is equal to. So let's do a couple examples of this. I'm going to do one here. Actually, I'm going to stop this video here. I know it's nice and short, but I'm going to put two examples in the next video, and then we're also going to talk about a third idea. So we'll keep this one short.